this video is intended to review permutations and combinations, which is a topic you learned in integrated algebra. So whether we're dealing with permutations or combinations, this is a way of choosing R things from a set of N things. So how many ways can something happen? N will always be your total, and R will be how many you want out of the total. The main difference between a permutation and a combination is order mattering or not mattering. So when order matters, we're dealing with a permutation. And when order does not matter, we're talking about a combination. And order not mattering for a combination. So if we're talking about a permutation, this would be picking a team. If you're picking, let's say, a captain, a pitcher, and a shortstop from a group of your entire team, that would mean order matters. It matters if you're in the captain position, the pitcher position, or the shortstop position. If you're picking your favorite two colors, but you're saying one is your first favorite color, one is your second favorite color in that order, that would be a permutation. Or first, second, and third place winners, again, order matters if you're first place, second place, or third place. Combinations would be something more random. So if I'm just picking 3 team members from a group and I don't care about their order, I would be dealing with a combination. If I'm picking 2 colors, but I don't care about which is my first or second favorite, or picking 3 winners, again. If you notice, in any of these examples, there's no type of order. Just so we can review where these buttons are in the calculator, if you go to your calculator, we have a whole probability menu. So if you hit math, if you scroll to the left once, you'll come over to probability. Ooh, this is an updated calculator, so I actually have a whole nother menu, so you can ignore that. If you're in the probability menu, you can notice choice 2 and choice 3 are NPR and NCR. P stands for permutations, C stands for combination. All right, so let's see if we can recall how to work some permutations and combinations. Example 1 is talking about how many different 3-letter arrangements can be formed using the letters of the word Ben. So if we just think about this, B-E-N, how many ways can we arrange those letters? Well, if you take a look here, it's a little smaller, you can see that there are 6 ways that we can arrange the letters in the word Ben. So what we're really doing there is we're saying there's a total of 3 letters here, and I want to choose 3. But am I putting a P here or a C here? Now the reason I know it's a permutation is because I'm saying that B-E-N is different than B-N-E, or N-E-B, or N-B-E, or any of these. I'm saying the order matters because each order is individually important. If I said that I just want to see how many ways can I arrange Ben and order doesn't matter, then it would just be one way, and that would be 3C3. So let's just practice typing these in. When you go to type in a permutation or a combination, you need to type your total number first. So if I type 3, then I would go math, probability. If I first want to try the permutation, which the question was actually asking, I would type in 3P3, and I get 6. That's standing again for the 6 total ways I can arrange Ben. If this question had, let's say, specifically said order doesn't matter, then we would be using a combination. And you'll see if order doesn't matter, there's only one way to arrange the letters in Ben if I don't care about the order. Now, for example 2, now I'm talking about, again, a 3-letter word, Bob, but in this case, Bob doesn't have 6 ways to arrange it. And now that seems a little confusing because the last word had 3 letters, but we had 6 ways of arranging Ben. Now, if we notice, in Bob, we have 2 repeated letters. So I should still be choosing 3, permutation 3. If you look at the top of your notes, if you notice there's a special case here, NPN is really equal to N factorial, in this case 3 factorial, and just to review factorials from integrated algebra, that would stand for 3 times 2 times 1, which is 6. But the reason our answer isn't 6 is because we need to divide out the repetition. Because I have the letter B repeating twice, I would be dividing by 2 factorial. So if I go to my calculator just to figure out where factorial is, because I'm doing a fraction here, I'll get myself set up. If I type 3 and go back to the probability menu, you'll notice choice 4 has that exclamation mark. Now I'm dividing by 2 factorial because I have a repeated letter. And you'll get 3, which is the only amount of combinations I can use for Bob since the B is repeating. Question 3, Now we're dealing with the word Savannah, which has 8 letters in it, and it's asking us which expression represents the number of different 8-letter arrangements that can be made if each letter is used only once. So we don't want repetition. So if you take a look at the word Savannah, we have a couple repeating letters here. A is being repeated 3 times, and N is being repeated twice. So since there are 8 letters, I would start by doing either 8p8, which is technically 8 factorial, but because I have some repetitions, I would first need to divide by 3 factorial. That's taking into account my repeated A's. And then 2 factorial takes into account my double N. So this would be equal to choice 2. When you have more than one repeated letter, you multiply by the repetitions. So this would be divided by 3 factorial, 2 factorial. All right, for example 4, we're being asked about a bowling team at a high school. They want to choose a president, vice president, and a secretary. If the team has 10 members, which expression could be used? Well, 10 would be my total, so that's my N. And I'm choosing 3 positions, so that's my R. And because these positions have an order, this would be a permutation, 10p3. In example 5, we're being told that we have a blood bank needing 20 people to help with a blood drive. If 25 people volunteer, how many different groups of 20 can be formed from the 25 volunteers? So my N is 25, that's my total amount of people. The amount I want is 20, that's my R. And since I'm not talking about any kind of order here, I just want a group of 20, this would be 25C 20. So again, I go to my calculator here, type in 25 first, then go to my probability menu, go to choice 3 for combination, type in 20, and there are 53,130 ways I could make these groupings. Now, each question we've done so far has just been talking about how many ways can something occur. We haven't really gotten into probability yet. If you notice in question 6, as you get down towards the end, it's asking me for a probability. So just to review, probability is when you take the number of things you want and you divide it by your total. So what do I want out of my total? So if I think about this, in example 6, the astronomy club has 25 members, 11 girls, 14 boys. The club wants to form a committee of 4 members to organize their annual astronomy night. What is the probability that the committee form consists of 2 girls and 2 boys from the club? Okay, well, let's break this down. If I want a group of 2 girls out of a total of 11, that would be 11 combination 2. Again, there's no order, so this is a combination. I also want a group of 2 boys. Well, I have 14 total boys, so that would be 14 combination 2. Now, if we go back to integrated algebra, this word and means something specific. It tells us to multiply. If this had said or tells me to add, whereas and is going to tell me to multiply. So I'm multiplying the amount of ways I can get groups of 2 girls out of 11 times the amount I can get 2 boys out of a total of 14 boys. But because this is probability, all I've figured out so far is what I want. The total would be the 25 total people, and I'm choosing a group of 4. So if I go to my calculator now, I can open up a fraction button, go type in 11 for my total number of girls, go to probability, combination, I want 2. I'm going to multiply that by the 14 boys I have with a combination here of 2. I have 25 total people, and I'm going to choose a group of 4. So the top is what I want out of the fact that I have 25 people, and I want groups of 4. Now, because this is a probability, probability should always be between 0 and 1. 0 tells me that an event is not going to happen. 1 tells me an event is absolutely going to happen. So this means the event is certain, meaning there's no possibility that it doesn't happen. And this tells me the event is impossible, meaning there's no chance of it happening. And probability should fall somewhere between 0 and 1. So my number here is 91 over 230, which is one way of writing the probability. if I wanted to think about it more in terms of percents or a decimal, I could change this to a decimal, which is approximately 0.33956, which is, if you round to, let's say, the nearest hundredth, it would be 0.40. So this is about a 40% chance of occurring. And let's just look at one more question. In example 7, we have 3 marbles. We're drawing them at random. So anytime we're dealing with random selection, we're talking about a combination. Without replacement, we have a bag containing 15 red, 10 blue, and 5 white. Which expression can be used to calculate the probability of drawing 2 reds and 1 white? Well, the probability of getting 2 reds out of a total of 15 would be 15C2 and 1 white. So I have 5 white, and I want to pick one of them. The reason I have a multiplication here is because of that word and. Now the total, if you look at this, I have 10 blue, 15 red, and 5 white, which means I have a total here of 30 marbles, and I'm trying to choose 3 of them. Specifically 2 red and 1 white, but that's your numerator, that's what you want over your total. So again, I can go to my calculator, open up a fraction button, I have 15 reds, and I want to choose 2 of them. Sorry, and I'm multiplying it by my 5 whites that I'm choosing 1 from. Out of my total of 30 marbles, and I'm choosing a group of 3 of them. So in fraction form, I get 15 out of 116. But again, if we're thinking about this more in terms of percents, I could turn this into a decimal and I get approximately 13% as my probability of this occurring. But if you left it in fraction form, that is correct. And if you notice, I went way ahead of myself here. I only had to answer this and say it was choice 1. Because this was a Regents question, if we wanted to narrow this down, the second it said that it was a random selection, I could have gotten rid of every single choice that had a permutation in it, and I actually could have answered this without doing any of the work. But since we're reviewing old topics, I wanted to make sure that we reviewed typing it into the calculator and converting it into a percent. So please rewatch this video. If you have any questions, come to Extra Help. Please also make sure that you filled in your worksheet as you watched it. If you need to go back and repeat any of the questions, please rewind. We're going to start off with combinations in class on Wednesday.